Covalent compounds. So these are molecular compounds. They're covalently bonded atoms. These contain two nonmetals, absolutely no metals. So if you're scanning a formula to identify if it's ionic or covalent, no metals means covalent. And they contain prefixes as part of their names. So we'll deal with naming compounds first. You name the first element. The ending on the second element changes to IDE, just like for the binary ionic compounds. And then the subscripts become prefixes to describe the number of atoms. So we've got 1 is mono, 2 is di, 3 is tri, etc. Now there's a star beside the mono, and that's because mono is dropped if it refers to the first element in the formula. So we don't say mono carbon dioxide, we just say carbon dioxide. Okay, so let's do a couple of examples. CF4. Well, C is carbon, and F is fluorine, so it becomes fluoride. Oops. Not thinking ahead here. Fluoride. And then the carbon, there's one of them, so it would be mono, but we drop that because it's the first element. And then the 4 is tetra. So this goes in front of the fluorine because it refers to the number of fluorines. So the subscript becomes a prefix and you attach it to that element. So this is carbon tetrafluoride. The next one is phosphorus. And the second element is oxygen, so it becomes oxide. And then we're going to deal with our subscripts. So 2 means di. So this is diphosphorus. And then 5 is penta. Now with oxygen, we can drop the A from penta or deca, and that's just because it sounds weird. Pentaoxide, pentoxide. So generally the rule is you drop the A if it sounds weird, and it usually sounds weird with oxygen. So this is diphosphorus pentoxide. So this is one word and this is one word. HF, so this is hydrogen. And this is fluorine, so it becomes fluoride. So there's one hydrogen, so the mono gets dropped, and then there is one fluorine, so that would be monofluoride. But in normal cases, we don't say hydrogen monofluoride. We tend to drop the prefixes on the second element if the compound starts with hydrogen. So this is more commonly known as hydrogen fluoride. But that's only if the compound starts with an H. And this is for covalent compounds. This is not acids. All right, writing formulas. So you write the symbol for each element. The prefix indicates the number of atoms of that element, and that prefix becomes the subscript of that element. So the prefix becomes the subscript. Oops. There we go. The prefix becomes the subscript of that element. We don't write the subscript 1 as it's understood already that it's present. So sulfur hexafluoride. Sulfur and fluorine. So there's the fluoride. Sulfur has no prefixes, so there's only one of them, and we don't write ones because we're efficient. And then hexa means 6, and we get that from the table of subscripts. So there you go, right there. 6 is hexa. So that becomes a subscript. The prefix is the number of those atoms. Phosphorus pentachloride. So phosphorus is P, chloride is Cl. There's no prefix with phosphorus, so we know that there's only one. And then pentachloride. So that means there's 5 chlorines because penta means 5. And the subscript always comes after the element, even though the prefix is in front. So penta, the name is in front, but the number goes behind in the formula. Now, one more, diphosphorus pentoxide. So this is telling us we've got phosphorus and oxygen. So P and O. And there's di, so 2, and pent is 5. So there's 2 phosphorus pentoxide, 5 oxygens. So the prefix is out front, but the subscript is behind. And that's how you write formulas for covalent compounds. This is the only place you use prefixes until we get to hydrates. But this is it. Do not use these with any ionic compounds except for hydrates. And those are a very small group of compounds. So do not use them in binary ionic. Do not use them in multivalent. Do not use them in polyatomic. Strictly covalent right now.